Hello, this video is to help you understand how to graph sine functions. So what we're going to do here is we're just going to graph the basic function y equals sine of x. So I'm going to write that right up here. Y equals sine of x, and this is what we're trying to graph. One way of graphing functions, just in general, this isn't particular necessarily the sine of x, but it's to do an xy chart. So I'm going to do that over here in this corner and start picking some numbers that I think will help you understand how the general graph works. In order to understand these numbers that I'm picking here, it's very important that you remember the unit circle. So if you've forgotten that, please go back and revisit it. So what I'm going to do here is I'm going to pick certain values of x and plug them into the sine function to figure out what the corresponding value of y is equal to. So let's say x is equal to 0. Well, we know from the unit circle that y would also be equal to 0. What other values are on the unit circle that we can use? Well, typically when graphing sine and cosine functions, your teachers want you to be in radians, not degrees. So I'm going to put some radian values in here. Let's say maybe we did pi over 3. Well, pi over 3, the sine of pi over 3 would be root 3 over 2. Next we do pi over 2. That would be 1. And we could keep going with this, or you could just see how I'm developing this as a method for graphing it. There are simpler ways of doing so with these functions, but you could actually go through and plot all the unit circle points. So let me go ahead and just plot these ones right now. So the point 0, 0 exists. Let me add an axis here. Okay, so these axes, these are going to be at intervals of pi over 2. So this would be pi over 2, pi, 3 pi over 2, 2 pi. And over on this side, we would have the negatives of all of these. So negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Now, as far as my y-scale axis, it's going to go from negative 1 to 1, because if we think about the unit circle, those are the values that y can take. So I'm going to go ahead and I'm going to put negative 1 down here. And I'm going to put positive 1 up here. And now I'm going to go ahead and graph this. Actually, I'm going to change that scale a little bit. Let me do that very quickly. I'm going to put negative 1 here, and I'm going to put positive 1 here. There's no reason for that, just I think it's going to make the graph look a little bit smoother in the end. So plotting these points to start, we're going to start with x, where x is 0, y is 0. So that would be this point right here. Let me pick a different color. Let's do fern. Let's not do fern. We're going to do this. Okay, so that would be our first point. Our next point is pi over 3. Well, pi over 3 would be somewhere in here, and root 3 over 2 is about 0.8, so I'm going to plot that right around there. And pi over 2 comma 1 would be right here. So let's kind of keep going around the unit circle, and if you've forgotten it, you should refer to it because this should be memorized at this point. What's the sine of, let's see, 2 pi over 3? Well, it would also be root 3 over 2, so that would be right here. The sine of pi would be down here. And I can just kind of keep picking points, and we see that we start to get this shape right here. And this is your characteristic shape of your sinusoidal functions. So I'm going to go ahead and I'm going to try to draw this. Might be a little tricky, but they come up very steeply through the middle. They kind of loop over, and then they start to come down. They go very steeply. I'm going to redraw this. This is not turning out too well here. So they come up through the middle very, very steeply, and they go around the top and kind of curl. And then as they get down to the middle again, very, very steeply. And as they approach the bottom, they start to curl again. So these are the shapes that they're going to look at. This is not a very smooth graph. In future ones, I'll show you better graphs. But this is the typical shape here. We can see that they just kind of oscillate up and down. And as you go further in math, you'll learn that these are used to model oscillators or pendulums. It's just going to simply follow the same pattern going back. So it goes down, flattens up, stays flat, gets steep, flattens out, and comes back down. So this is not a great looking sine graph, but just the basic idea of how you can use the x and y coordinates to model this. And in fact, you could actually do the same thing for cosine. So I'm going to do the cosine, small xy chart for cosine down here. Well, where x is equal to 0, I'm going to do this over here, y equals cosine of x. So where x is equal to 0, we know y equals cosine of 0. Well, that would give us y equals 1. Again, if you're lost, it's because you don't know the unit circle. We really need to go back and look at that. Let's say it's pi over 3. Well, where it's pi over 3, cosine of pi over 3 is 1/2. If we do pi over 2, we get 0. If we do cosine of pi, we would get, let's see, cosine of pi would be -1. But what I'm really trying to get you to focus on is how the pattern is followed. So cosine starts up here. If I go to pi over 2, I end up here. If I go to pi, I end up here. You can see it's following the same pattern. It's almost as if it's trailing this sine function. It's following it. It's just a little bit behind. So let's see what this graph would look like. It would come down like this. Again, curl up steep and over like this. This is very difficult to do on a pen tablet, so sorry these look so sloppy. On this side, it would come, break down, whoop, curl up, very steep through the middle, and up over the top. So these are your sine and cosine functions. You can see that they're very similar to each other. They're just shifted over. What you're going to learn later is this is because of a trig identity that relates sine and cosine. So this is an introductory video. You probably covered this in your class at this point, but just wanted to remind you of how you can do this. In the next video, I'm going to describe how you can use the amplitude and the vertical shift to plot functions of sine and cosine as well.